Okay, so we're doing page 80, golf ball problem. Okay, so we got a cliff. It's at 30 meters high. Okay, we'll use this here as our reference. Ball is shot. So we're going to try to find this distance. And so our end goal is to find that distance, the time it takes to reach there, and V final. Okay, so we know V initial is 25 meters per second. So we're going to break it down. Elise, we're going to break it down as a triangle. This is our 25. This will be our X. This will be our Y. And we know this is 50 degrees. Sorry. Okay. All right, so let's break this guy. So cos of 50 is 25 on X. So therefore, X, nope. So that's it. So going to X over that. So we know that X is 25 times 50 cos equal. So we know this is 16.1 meters per second. Sine of 50 over 25, so Y is 25 times 50. So this is 19 point. We'll keep the 5 here, meters per second. So this is up, this is to the right. Okay, so now we know that this ball, when it reaches the top, will reach the velocity of 0 in Y, right? So when it's shot in Y, it goes zoo, and then it will fall down. So it starts at 30, it will fall to 0. But we know that, we don't know the height here, but we know that it will stop at the V final here will be 0. So let's try that. Go to my equations. If I use the second one, so we know that V final is V initial plus AC. So, sorry, so we're trying to find C. So C final minus V initial over A. So if I plug that in, so V final here is 0, so that's okay. So notice the two negatives here, this one and the negative 9.8, so it's good. So if I get 19.15 divide 9.8, so my initial, so my time is 1.95 seconds to reach the top. Okay. What I need to know now is the distance, right? So I know my time. So let's look at our equations. So I'm looking for D. use 4. We could use 1. What about we use 1? It's a nice, easy one. That's what I like about those equations. It's you use the one you want, depending on what you have. Okay, so D is, so V final, which is 0, plus V initial over 2 times T. You can drop all the deltas, okay, for those. I don't care for those. So V final is 0. So V initial is 19.15 divided into times 0.95. That gives me 15. Yeah, right here. Oh, what am I doing? Those are meters. Perfect. So I know that my total height for my ball is 18 plus 30. So this height here is 48.7 meters. Perfect. And now what I'll do is just find how long it will take to fall to the bottom. So we know it's 48. So we know D. We don't know the time. So we'll find the time for that. Okay, so I'm looking for time. So go back on the equations. But I don't know V final. So I have to use V3, equation 3, because I don't know my V final. So this way I'll be able to find the time. Is there an easier one? Oh, I can find my V final in Y using equation 4. I prefer that because I don't want to use the quadratic. I don't like that. So 4. So V final square equals V initial square plus 2A. V initial is 0. That's nice. And we'll land right on V initial in Y. So it'll be 2 times 9.8 times my distance, 48 point, what was it, 7 meters, which will give me 8 times 48, 7, and square root that. So I get my V final in Y, put Y here, is 30.9 meters. This is down. Okay. So I know my V final now. And I know a few things already. So I know my total time of flight. So T total, if I can call it. Oh no, sorry. I didn't find the time yet. Sorry. So what about we do that? So that's my V final. So what about we try to find the time? Use equation 1. Use equation 2. So I know V final, so I can use equation 2. So I get V final equals V initial plus a t, isolate t, divided by a. So v initial is 0. So my v here, to work in that equation, you should make it negative, right? So it's down. Okay, so the equate, because my acceleration is negative, right? But you can just think about them, okay? So right now I'm just going to use two positive values. So this value and 9.8, it will work. You guys should try to get used to that. T'as pas de travail, Elise. Okay, attends. Okay. Tantôt. 30.9 divided 9.8. So it takes 3.2 seconds to fall from the top of the vertex to the floor, to the ground. And we know that that was 1.9 earlier. So plus 1.9. 1.95. So I get, so my total time of flight is 5.1 seconds. Is that what the book lands on? 5.1, perfect. My total distance traveled, so my dx, well, I just take my time, and my vx was here, this one. I just multiplied that velocity times the time, so the 16.1 meters per second. And what will happen? It will cancel seconds, and so I get 16.1 times 5.1, so 82.11 meters. That is the answer, but because I had 25 meters per second, it's going to be just 82. So this, and next I need to find my V final total, right? So the resultant. So I know a few things now. I know my V final. What's this? So now I have a triangle that looks like, oh boy, looks like this. Okay. My y is this one, 30.9. My x here was this one here, 16.1. Per second, that's meters per second. So I need to find the hypotenuse, 16.1 square plus 30.9 square equals square root. So this thing here flies down at 34.8. So we'll round it because now it's the final answer. So it's 35 meters per second. That's my direction. So it's down. But now what's my angle here? So you'll do whichever, cos or tan or sine, it doesn't matter. I'm using a lot of cos recently, no reason why. So cos of theta is 30.9 over 35. I should have kept a sig here. It was and then sine inverse of that, 30.9 divided in 35 equals inverse of tan of cos. I get 28.5 28 degrees, perfect. So it's 28 degrees right. And the book gives 62, right? They flip it, right? So in the book they find this angle, but I explained to you guys, I want it relative to down or to north or to up. Okay, so we're done.